So here is a log application, and this is going to be the pH of a solution. So this guy right here is just a formula for the pH of some sort of solution, and it's just equal to the negative logarithm of H plus. So if you've taken chemistry, or if you're gonna take chemistry, pH, pOH, and pKa, and all this other stuff are going to be useful here. So basically, pH is basically the power of this hydrogen ion. So if you have some sort of solution, right? You have some sort of solution right here. This hydrogen ion basically tells you how acidic or how basic the solution is. So usually the lower this hydrogen ion or the lower the pH, the more acidic this is. So if, for example, if I have, so here's like the pH scale. Let's say this is like -1. If you're over here, this is very strongly acidic, so it's strong. Okay, so we're gonna call this acidic, very acidic. So imagine battery acid. Battery acid is basically very acidic. If you are on the other side, you are basic. So let's say this is a 14, a pH of 14. This guy will be extremely basic. So kind of like detergent, okay, drain cleaner, that tends to be very basic. Usually a pH of 7 is neutral. Water tends to be around here, okay, at the pH of 7. So you kind of have kind of like the extremes here. So the way that we kind of calculate this is just basically taking the negative log of the H plus. Here, H plus is what we call the hydrogen ion. And then these little brackets are basically the concentration, okay, and the concentration is measured in moles per liter. Okay, moles per liter. Moles is just a unit of measurement in chemistry, per liter. This is usually molarity. We're not going to get into the specifics of chemistry in here. I'll let your chem teacher show you that. But basically, this is basically what it is. So that's what H plus is. One of the things about ions and atoms is that usually a lot of these guys have very small quantities. So you're going to see a lot of like scientific notation. So you're going to see a lot of like 2 times 10 to the negative 8th power. And this is going to be in moles per liter. So remember what this means. The negative 8 means that if you have a 2 here, the decimal is here, and you're going to move this 8 units to the left. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8. So in between these little spaces, you're going to write zeros. So that's basically what the concentration is at that point. So so it'll be 0.000000002. That's basically what that is. In your calculator, if you have the TI-36X Pro, what I want you to be able to write, so let's say you wanted to write 2 times 10 to the negative 8. So what you're going to write, you're going to first write down the 2. Then you're going to look for this button called EE. You're going to press that EE button. Then you're going to press a negative sign. The negative sign is given to you like this. And then you're going to write 8. So this, pressing this into your calculator, basically means 2 times 10 to the negative 8. So go ahead and practice it. So write 2 EE and then negative 8. Okay, so it'll give you this form, not the closed form, but more of the expanded form. Okay, so just keep this in mind. EE is basically the third button on the second row. The third button of the second column. So you can easily look that up. It's right next to the exponential E. So that's just something that you might want to consider doing because you're going to be doing this a lot. So let's do a couple of examples. This isn't too bad. This is actually a freebie. I like giving these questions on the exam because it prepares you for chemistry, and it also helps you practice with small quantities, and it's a freebie basically. So here we have human blood has a hydrogen ion concentration of 3.98 times 10 to the negative 8 moles per liter. So find the pH of human blood. So we know that the pH is just going to be equal to the negative log of the H plus. And we know what the H plus is in this case, which is going to be this guy. So this is going to be equal to the negative logarithm, and it's in base 10 because there's no base. So you're going to have 3.98 times 10 to the negative 8. So now all you really have to do is plug this into your calculator. So negative log, okay, press the log button twice to get to the log base 10 of 3.98, and then EE, and then negative 8. Okay, so don't write the 10. You don't need to write the 10. The EE stands for the 10. And what you should be getting is about 7.4. So that is the pH of human blood. So basically, it's about in the middle. It's not too acidic and it's not too basic. Okay. So now let's find out this guy. This actually should say solution, not chemical. But the pH of, let's say this is a solution, is 8.2, so it's a little basic. Find the hydrogen ion concentration. So still, let's just use the pH is equal to the negative log of the H plus. Now in this case, we're solving for this guy. We know what the pH is. The pH is 8.2 is equal to the negative logarithm of H plus. So first, let's get rid of that negative. So let's divide by the negative. You're going to get negative 8.2 is equal to log of H plus. How do we get rid of the log? Remember that we exponentiate. So we raise both sides by a 10 to get rid of the log. So you have that H plus is equal to 10 to the power of negative 8.2. So I'm going to put that in my calculator. So 10 to the power of negative 8.2. And we're going to get something really, really small. So 0.0, I don't know how many zeros that is. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then 6. Now this would be a perfect, this will be in moles per liter. So this will be an acceptable answer. Usually it will be better to write it as a scientific notation. So move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be 6 times 10 to the negative 9 moles per liter. So that's basically the hydrogen ion concentration. So these problems aren't really that bad. They're very easy to do. It's just an application of where logarithms are used. There's other applications about logarithms. There's a lot of differential equations that involve a lot of logarithms, but this is the one that I really want to focus on for this chapter.